what? Stress Y3. Okay. So we can also determine our stress Y3. Okay, so the stress Y3 basically, wait, how am I going to determine stress Y3? So this is our center of the circle. Okay, so stress Y3, wait, all of a sudden I'm having a brain fart. So we know there's another, so we just need to determine this offset. Okay, we just need to determine this offset now. Hey, so we know the distance, so I'm going to call this alpha, right? If this is alpha, over here is also alpha. So this angle over here is equal to 180 minus by 2 alpha. Okay, so I have to determine alpha. So alpha, tangent alpha, will be equal to what? Will be equal to 48 divided by, so the average is 48.04, so it's equal to 48.04. So alpha is 48 divided by 48.04 inverse tangent is equal to 44.97 degrees. Okay. So when there's 44.97 degrees, so 180, am I right? 44, 48 divided by 48.04 inverse tangent, 44.97 times 2 minus 1. So this is still also close to what? This is also close to 90 degrees. Okay. So I'm going to declare that stress Y2 is approximately equal to, also equal to the value that is, if it's approximately 90, so it's approximately equal to what? What is our X value? Stress X is equal to minus 50 megapascal. More important, can anyone tell me what is so unique about this solution over here? How many points we have on a circle? 3 points. Is this a 3D Mohs circle or a 2D Mohs circle? Okay. Now this is also a what? A 3D Mohs circle can be also equal to what? One circle. Why? Because on the circle you have point X, you also have point Z, and you also have stress Y2 or Y3. Yes or no? So all of them are on the same circle. Is the circle in the box? It is. Right? Yes. Right? Now the question is why this answer is wrong? Yes. Yeah. This is wrong because tau max is not equal to what? Is it 73? I can't remember now. Yeah, it's not equal to what? 73 megapascal. Am I right? Right? So this is why this answer is not what? Not valid. Okay. Now, there's another question. Okay, as I said, they put a star trying to tell us it's really tough, but it's not that difficult. Okay. This question over here. For the state of stress shown, determine the value of stress Y for which the maximum shear stress is as small as possible. Okay. The corresponding value of the what? The shear stress. Okay. So This is again a 3D Mohs circle problem, as you can see. Okay. And I deliberately post the solution for you to see, right? If you want to have fun, go and have fun. These are the solution, right? It's basically like a black box, okay? So I'm trying to convince you all, stop using the transformation equation like what they are doing and just draw the what? Draw the damn circle. Are we clear? Okay, just draw the circle. It's not that difficult at all, okay? So we start with this problem. Now this problem is one of the most like confusing one because there are some information missing. So what is different from this one is we don't have the what? Maximum shear stress value at all. Okay. So they tell us, okay, find all possibility, try to determine what is the value of the stress y. Okay. So fine. Okay. So we again, by doing this, we construct Mohs circle. Okay. Before we construct Mohs circle, we know that okay, I'll tell you what's in my mind first, okay? Part of doing well in this course is you have to get into my mind, unfortunately, okay? So I want to help you to think, okay? One thing for sure is stress Z is always equal to what? 0. Yes or no? Right? So when we did 3D Mohs circle, there are what? There are two conditions where stress Z is equal to 0. Can you remember? Right? So condition number 1, right? Condition number 1, can you remember when stress X is greater than stress Y, both are what? Both are positive and what? Stress Z is equal to what? 0. Can you remember this? Yes or no? Right? Another one, condition number 2, is where stress X is positive, stress Y is what? Negative, right? And stress Z is equal to 0. Okay. That is the other possibility, right? So now, let's see if we can use this condition to construct the possibilities of to determine our shear, okay? Our maximum shear stress, okay? So again, we start constructing Mohs circle, okay? So 140 and 80. Now, over here, what is missing is this. Can we draw the red box? Right? We cannot draw the red box because they did not tell us what is our what? Tau max at all. Right? It's impossible to draw the red box, okay? So let's look at our option, okay? At this stage, usually we start to panic. Okay? And it's normal. When I see the question for the first time, I'm like, holy shit, I panic. Okay? So I'm going to just focus on the positive. When I upload the video on YouTube, it's very smart, you know. It will detect what language I use. So whenever I use things like holy shit, things like that, it will censor. You realize that? And it'll take a while. You'll tell me one language wrong and okay. Okay, we do this again. Normal stress. Shear stress, element rotate clockwise, element rotate anti-clockwise. I don't know what's the shear value. Okay, I might be way off. So one thing is for sure is we know that over here, if you look at this problem, in fact, I've uploaded this problem on Avenue to Learn. We know that point Z is here, right? That is a no-brainer. And then there's a possibility that we are at 140. Okay. And then we have 80s. We know that at point, so we label this our X, our Y, or Z, anti-clockwise. So this is our point X. Okay. Now, point Y can be anywhere on this line. Okay? It can be anywhere on this line. Yes or no? But we don't have enough information. Some of you say, Eugene, why not we try this? If that's the case, we can do this. Yes or no? Like what we had before. We can have one side, and then we can also have this on the other side, right? We can have this on the other, like how we solved before. Yes or no? So if we know our value, we know what is our, we can determine what is our stress average here. We can determine our stress average there, right? But we cannot do this now. Why? We don't know what is our what? Tau max, right? So this is not possible, right? So one thing is definitely possible. Okay, one solution is definitely possible is that over here is your point Y. Yes or no? Because over here can be the center of your what? Circle, right? Point X to point Y. If you look at point X to point Y, the rotation is how many degrees? 90 degrees. On most circles, how many degrees? 180 degrees. So this is the other possibility. So we treat this as point O. This is as our what? Center of our circle. So from here, we know that stress Y can also be equal to what? 140 megapascal. In tension, positive. Okay. So now we have to construct our what? Our 3D mole circle, because this question wants us to find that the maximum shear stress must be as small as what? Possible. Okay. So from here, we can construct our first mole circle. So 80, so the thing is 40, 40, 80, 140 minus 80 is what? 140 minus 80 is 60. Okay. So this is our first mole circle. Yes. No. It's because X to Y, I'm treating 140 the center of the circle. Yep. Okay. Because this is the only other possibility. Yes or no? I don't have the maximum shear stress value. You cannot construct anything else. Okay. So we now know that this belongs to what? This belongs to the XY what? Plane. And then the next circle that we draw, this circle over here, now this is very interesting. Okay. This one can be for XZ or XY what? Plane. Yes or no? Because it's 90 degrees, there's no acute angle. Yes. And then the last circle comes in over here. So this belongs, again, it can belongs to your XZ plane or XZ or YZ plane, right? Because there's no acute angle down here, right? So from here, you can see that our tau max will be equal to 220 divided by 2, which is equal to 110 megapascal, right? Because the tau max happened on the what? Y, X, Y, and YZ what? Plane. Did we use any equation? To get the same thing, right? To get the same thing, can you believe the amount of work that you have to do? Can you see that? Right? That's why it grabs the concept of the what? Of the circle. Now, the next possibility is even worse. Look at this. Holy shit. Oh, stop swearing. Or not, you get censored again. Right? You look at this and really. Now, what they are doing over here is in fact constructing Mohs circle mathematically. Are we clear? Right? Don't waste your time. Just draw the what? Let's draw the circle. Now, the next solution is more interesting. Okay. The next, so okay, I will stop here. I'll not see you on Good Friday. I'll see you on Tuesday.